Ray, I've been wanting to connect with you ever since Andrew's presentation last month. And was it your feeling that what he is doing in terms of the pyrolysis is a positive best practice? What were your thoughts?
I think that yes, it is my answer to your first question. And if we think about the example that Barb showed of the group in Africa, the the plastics in developing economies are basically not managed. And so if we move that plastic from a local village site to some other site, it's still not managed, right? It just moves the potential malaria or dengue vector reservoir. At the end of the day, we need to do more about actually cleaning up the mess. We need to reduce it, like Barb was saying, and they're having some great successes doing that. But we still need to clean up the mess we've made. And that has to be done in a way that's meaningful and not just buried. Because as the bacteria and fungi work to break down plastics in the ground, they're still creating new chemistry. And we don't know what that is yet because this is a relatively new evolutionary process where these critters are actually unlocking the chemistry of plastics and figuring out how to metabolize parts of it. And so we don't know what the biological residues are from that. We do know that bio-based plastics are still plastics. They're still polymerized organic molecules that, if they have the same qualities and characteristics as petroleum-based plastics, do deconstruct to a lot of these same very harmful chemicals, with the added impact, potential impact of doing things like taking food crops out of rotation so that we can make plastic. And that doesn't seem like a win to me. But that aside, forward momentum on cleaning up the mess has to continue. And I really do think that we've been engaged in this dynamic really since Rachel Carson wrote her book in the late 60s, and the Cuyahoga River caught on fire, and there was this great environmental awakening that occurred in the United States that kind of bled over into the rest of the world, more or less. Started with DDT, and so we ended up in two camps: the people who were concerned about these kinds of challenges, and the people who were in the industrial productivity, progress, economic growth camp. And I got to say that while that has created a bunch of new knowledge, it hasn't really advanced the kind of effectiveness of our problem. We're still falling behind. And this is from 2009, when they really kind of first framed up this concept of planetary boundaries, until now. 2023 was their most recent assessment. We're not gaining on these problems. The only one that has actually kind of gotten better is stratospheric ozone depletion. And if you look from 2015 to now, it's minimal. From 2009 to now, it's not getting better. It's just that it's within the safe zone. And atmospheric aerosol loading, I think that we haven't quite figured out how plastics fit into that. But nanoplastics it's literally every breath we're taking now, and it comes out of our clothes dryer or wherever, because all of our clothes are plastic, or they have some plastic content, you know. So we really need to figure out how to plug into the economic models of industry so that they recognize that it's profitable to be good stewards across all nine of these planetary boundaries, and stop thinking about climate as the only thing that's an emergency. If we integrate these nine planetary boundaries with things like the 17 Sustainable Development Goals that the UN has put forth as mechanisms for achieving, I don't know if we'll get to safe operating space, but for mechanisms to achieving some kind of improvement in these planetary boundaries, and we start to quantify, and we start to incentivize industry through quantitative economic information that shows how profitable it is to not be wasteful of fresh water, or nutrients like phosphorus and nitrogen, or what we're doing with novel entities like plastics. Then the greed gene takes over and these problems start to go away, because the greed gene is what got us here, right? And everybody wants to make money, but We have allowed industry to export cost to the environment and export cost to poor communities and put it in their ledger as profit. And so these circular economic models that rely on taking the waste from one industry and having it be the input for another decrease the amount of waste that ends up being exported to the environment.
So is the geo trash where you're taking this waste out? I sent the information about that to someone who follows pyrolysis very closely. And I don't know if she looked at the information, all of it, but it was basically this non-starter of this is just another one that's just trying to solve our problems with something that's creating other problems. And then I sit back and I go, okay, well, is this at least directionally helpful? How much are we trading the cleanup of plastic and all solving a lot of these other problems? And are we creating a dirty fuel out of this and a dirty, what was it, biochar, whatever it is? This is not my specialty, but are we trading one for the other, or is there a directional movement forward with the equipment and the process that Andrew is doing with geo trash?
So the answer to that depends on your values. The shortest answer is yes, everything is a trade-off. Everything is a trade-off. Do you value better health outcomes for pregnant women more than you value some other part of your value system, like clean water or the ability for your community to go fish where they've always fished? These are the important questions that need to be wrestled with. So, yes, everything is a trade-off.
Right.
Everything is a trade-off. But the degree to which we're willing to say that this is a no-go line, one, in my opinion, needs to be based on a substantial knowledge base for what happens when we cross that line and what are the benefits and what are the impacts. And if we just think about it, every one of these boundaries is as some kind of moment to do a mass balance assessment. What are the goods? What are the bads? What are the inputs? What are the outputs? Because they equal each other in terms of mass balance. In terms of a value system, these things get muddled by all kinds of things. And I'm trained as an ecologist, and at its most reduced kind of reductionist form, ecology is the study of the movement of materials and energy across boundaries. But also, the most important first principle of ecology is that there are no unexploited resources. So when we do things like restoration ecology, where we're trying to restore some kind of salt marsh or something, all of the things that contribute to impacts need to be understood. And some of those things affect people directly. Like if you're going to restore a salt marsh, then you need to restore the sediment dynamics. And restoring sediment dynamics affects people's property because now the beach is going through its natural longshore transport processes, and that takes away somebody's beach that they spent a lot of money on, right? So these things become very complicated very fast. And so that's why the longer answer is, well, it depends what your values are. In the shorter term, we don't have a better solution set for actually dealing with plastics than pyrolysis and gasification, in my opinion. But this is based on my ecologist's set of values. I don't see a solution yet that can meaningfully clean up the plastics mess that we've created. We're starting to really understand it to the point where everybody who comes to an event like this one goes away feeling like they need to ring the alarm bell louder. But what I don't see very often is people going, okay, and now what are we going to do with it? Because it doesn't go away on its own. You can't bury it and have it just be okay.
Now is what I've been wrestling with, the big cleanup of rivers. What do you do with everything you've cleaned out? And the answer is typically we recycle whatever we can. This is dirty plastic. That to me says you're either burning it or burying it somewhere else.
Or it's
And
just not managed. There's a river in the Dominican Republic that's the biggest contributor of plastics to the Western Hemisphere, and it's one of the biggest contributors. But there's no solid waste management infrastructure in the DR. And for all of the coastline of Haiti that's affected by the plastic exports from that river, there's no waste management infrastructure.
Right,
So
right. There's this transboundary plastic that is just going everywhere to people depending on where the currents take it. But my question is always, if it's there and this technology is there, why are we not doing it in the United States?
we are.
We are
Yeah.
responsibly.
Yeah. It's happening. There are economic constraints. And so it starts to scale and make people money when they cross a certain size threshold. So right now in the United States, there's a giant pyrolysis plant. I want to say it's in Maine, and there's one being permitted in LA County where they will use this technology to, as soon as they get their permit sorted, to deal with the plastic waste that's generated in probably most of the West. But also, it's against the law to landfill plastic in Japan. So they have a giant pyrolysis facility in Tokyo Bay, and all the plastic in Japan goes there, and they use it to power part of the city. So, yes, there are trade-offs. There are absolutely trade-offs. The important questions to ask though are, is this trade-off worse than that one? If we're just going to throw our hands up and say we're not doing anything until there's a perfect solution, then we're going to watch this mountain of plastic just grow, grow, grow.
He was talking about how he met EU regulations with
Yep.
his pyrolysis machine. Is the United States meeting a higher level or a lower level of standards?
Well, our EPA is in flux at the moment.
Yes. But were we meeting the EU higher standards?
um, the U.S. Clean Air Act requires the Environmental Protection Agency to enforce healthy air standards in the same way that the Clean Water Act requires them to enforce healthy water standards. For some of these constituents, there are no standards. And so the work needs to be done in order to do that. And if we just fired all of our government scientists and made things like the phrase climate change basically against the law. This is a very Stalin-esque moment in our history that's terrifying from that perspective. So the shortest answer is I don't know. The EU tends to have pretty strict regulations on things like this. Like they don't use certain dyes in their foods that we use all the time, things like that. So they're ahead of us in many respects in a lot of these kinds of areas. The thing about pyrolysis and gasification that make them useful technologies for this particular problem is that they break apart the molecules based on molecular weight. And so the very first light hydrocarbon gases that come off end up being recirculated into the chamber to generate the energy to run the chamber. So a lot of the exhaust like that you would experience in something like a medical waste incinerator, where instead of recycling the stack emissions, they try to scrub them, right? So those technologies are different. And they don't take the flue gas and recycle it until it's broken into carbon, hydrogen, and oxygen. And that's what happens in a pyrolysis generator. That exhaust gas gets recycled until all the calorific value of it is extracted. And that means that perfect oxidation of a hydrocarbon, you end up with CO2 and water, right? Have you ever heard of a kangaroo rat? So kangaroo rats don't drink water in their
That's
lifetime. All the water they get is because their digestive systems are so efficient that they create metabolic water from the hydrocarbons that they consume. So they don't drink water. It's all metabolic water. That's basically the concept behind recycling the exhaust emissions into the pyrolysis generator. A lot of that, like the exhaust problem, is it goes away because those things just get consumed. And yes, there are a terrifying number of moles of carbon that are locked up in plastics. And if we convert all that stuff to fuel and then oxidize it, we're not going to help ourselves with respect to greenhouse gases. But with respect to these other planetary boundaries, we may make some headway. And the other thing about the plastics is, or the pyrolysis of plastic, pyrolysis is such an efficient process that about 80% of the material by mass ends up either becoming a heavier fraction of petrochemical that's very similar to diesel fuel, and about half of the so 80% of it. So and then 40% of or half of that, so 40% by mass becomes diesel fuel, and 40% becomes naphtha or gasoline weight fuel. That naphtha is extremely valuable to the petrochemical industry, because if they're going to do business in the European Union, and almost all these are big multinationals, right? And they do business in the EU, they got to meet the EU regulatory minima by 2030 and 2050. And they're terribly polluting industries. So they need to buy all of this recycled plastic so that they can then say, this is recycled plastic. And it has a lower carbon footprint because it's now had a different life before. Now it's recycled into new plastic material. And so they really need this.
Does it all reduce production of oil, virgin oil?
So it changes the fraction that's used to make plastic. So now we don't have to just pump oil to make plastic, because we have existing plastics that we can break apart into their chemical constituents to make new plastics. So that 40% of the plastic by mass becomes feedstock for new plastic. And it's extremely valuable. And then 40% of it can be used to do things like run a diesel genset that can then be daisy chained up to a desalination plant to make safe drinking water in a community that's off the grid, or some other kind of thing, right? It can be sold at marinas so that artisanal fishers can fuel their boats. And we can incentivize people. The real benefit of all of this is that you're taking something that has a value that is less than zero. It's a liability on a ledger sheet. Plastic waste is just something that the cost of managing becomes socialized, right? Now we take that material that has this value of less than zero, and we can generate money to pay people to go collect it and bring it to these facilities where we can manage it and convert it into money or some other force of energy. It's a circular kind of ecological way of taking advantage of the energy that's locked up in plastics. Convert that into social good, convert it into money, convert it into new energy. Because at the end of the day, Newtonian laws of conservation are still in effect, right? There is no new creation of anything. It's just translated into a new form.
I feel like even the word recycling bothers me because we're not really recycling, we're downcycling, we're repurposing. When you actually go into something like a pyrolysis, you're maybe doing a little bit of all of it. You're repurposing it. You are recycling it at a different level. All of it has its negatives, and it is a trade-off. But if the trade-off is incrementally moving us forward and helping to get rid of disease or get rid of cleaning up areas, to me, that is a positive trade-off. And who knows, a year from now, there'll be a newer, better piece of equipment that will evolve the situation further.
I
Is
think
that
most
the summary?
assuredly there will be. There will be new technologies as long as we stick with it and we continue to find the weak spots, then we can fix those. But I see so often just recalcitrance with respect to actually solving this problem. And everybody knows it's bad, but it's like the arguments against an electric car from a couple of years ago, right? Well, the amount of energy it takes to mine the minerals and blah 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 exceed the impact of burning the fossil fuel. It turns out that's not true, but those narratives get out there and then they become true, whether or not there's any veracity or in their relationship with reality. They become the truth that govern our social trajectory. And that's unfortunate because we're not actually making information based decisions. It's just like this is what proliferated on Twitter, and somebody benefits from having it there, and so they promote it and blah blah blah.
Why we people are not banning it?
I think that it's very difficult to mandate something like that. I think that while we need to have important regulatory frameworks that allow us to do things like be more honest in our accounting of the impacts of plastic. There's a narrative out there that it's very cheap. But consider this, all along the supply chain for plastics, the drilling industry pumps that oil out of the ground and then they sell it, right? They make profit when they sell it. Then that material goes to the plastic petrochemical industry where they make plastic. They make a profit there. The plastic industry then sells that to companies that make containers out of it. That industry makes a profit when they sell their containers. Coca-Cola puts their product in that container and they make a profit when they sell their product because it's in this very inexpensive container. Then the consumer, you and I, we buy our bottle of Coca-Cola and we drink it and we're stuck with this container that we don't want. So what do? We take that container and we put it in a bin that says recycled, or it just goes in the trash, or it just gets pitched aside. Whatever the case is, if it goes into a bin called recycling, then the municipality where that event occurs, where that thing goes in the recycling bin, the municipality then assumes the liability of managing that plastic. So it goes to a sorting center, and most of it then goes to a landfill. And the municipality is on the hook for the cost of managing that part of it. If it just gets discarded, then society in general gets to deal with all the costs associated with that. So in the first 4 phases of its life, plastic generates a profit for private industry. In the last phase of its life, it creates a cost for society. So when we think about where the cost associated with managing that plastic should come from, we've got 4 different levels of profit that we could pull from so that society doesn't have to bear the cost of managing this plastic after its useful life. But we're not doing that yet. It's starting to happen in the EU.
That's a very important thing that you just said, is that there is this narrative that plastic is cheap. The narrative that it is cheap is this tiny little window of where it gets sold. And that's why I was bringing up earlier the statistics now that are coming out about health related costs.
Yeah, and so life cycle assessment is a very useful and well thought out tool set for quantifying where those impacts occur. I'm arguing that we need to include all 9 of the planetary boundaries in life cycle assessments and not simply carbon and climate. Because when we make statements like plastic is very cheap, we're not considering how it affects freshwater or land system change or biosphere integrity. We're only considering whether or not it contributes to greenhouse gas. And that right now is a very limited, very narrow, and inadequate, in my opinion, perspective on the impacts of all of our activities. Because, you can't forget, Newton is still in effect. Everything is a trade-off, right? There's nothing new. The only subsidy we get on this planet is from the sun. Everything else derives from some material that we transform into a different material, right? The Newtonian laws of conservation are still in effect. And so it's not like, we created this new material called plastic, but what do? We converted oil into plastic. And, luckily, the energy content of plastic preserved the energy content of the oil. And so that creates an opportunity for us. And with technologies like pyrolysis and gasification, we can convert that into a more usable, more safely usable form of energy. And also the fact that plastic has already had a life, even if it was a single use, before it gets converted back into energy or into new plastic feedstock through pyrolytic processes, decreases its level of impact overall.
Dr. Timm Raymond, thank you. You're always so generous.